Hello class, this week we are going to be talking about introduction, configuration, and management of the DNS server role in Windows Server 2008. DNS provides name resolution. In other words, the primary function of DNS is to translate human-readable host names such as Microsoft.com to network-required Internet Protocol addresses or IP addresses. DNS also assists the flow of email by providing the mail exchange record that tells a simple mail transfer protocol server where to send an email message. DNS is supported on the internet by thousands of distributed servers or DNS servers that maintain all the records necessary to the name for the name resolution. These servers use a client-server model of networking where the DNS server provides information to the DNS clients or DNS resolver who requests name resolution information. Many of these servers host zones that include records for specific domains or subdomains that they are responsible for maintaining. Before studying DNS, there are some terms that are important to know that are listed in this slide, which are DNS namespace, DNS domain, fully qualified domain name, host, host name, DNS record, and DNS zone. A DNS namespace is a hierarchical tree-structured list of the DNS host names started at the unnamed root that is used for all DNS operations. The root domain is represented by a period. Under the DNS root domains, we find the top-level domains or first-level domain, and these ones are organizational types such as .org, .com, and .edu. There are three types of top-level domains: generic, country code, and infrastructure domain. DNS uses the fully qualified domain name to map a host name to an IP address. The FQDN describes the exact relation between a host and its DNS domain. For example, computer1 that sells.microsoft.com represents a fully qualified domain name. The computer1, that is the host, located in the sales domain, located in the Microsoft second level domain, located in the .com top level domain. Second level domains are registered to individual or organizations, such as Microsoft.com, which is the Microsoft Corporation domain. Second level domains or DNS domains can have many subdomains, and any domain can have host. A host is a specific computer or other network device within a domain, such as a computer one in the sales domain of the Microsoft.com domain. One benefit of the hierarchical structure of DNS is that it's possible to have two hosts with the same host name that are in different locations in the hierarchy. For example, one host named computer1, which is computer1 that sells.microsoft.com, and another one named computer1 as well, but it's in the cpndl.microsoft.com. They can both exist without conflicts because they are in different locations in the namespace hierarchy. The idea with this last example is to understand what is the DNS namespace, the DNS domain, that is the portion of the namespace to the right of the host name, which is made up to for two parts, that is the top level domain and the second level domain. What is a fully qualified domain name? What are hosts? What are host names? Which host is the computer on the internet that provides a specific resources, and the host name is the name given to a computer or host to make connecting to it easier. This host can be part of a subdomain, that are part of a second level domain, that are part of a top level domain, that are part of the root domain. And finally, in our list of terminology, we have the DNS zone and the DNS record. The DNS zone consists of a collection of connected nodes served by an authoritative DNS name server. A zone can be a single domain namespace, such as Microsoft.com, or it could be a multiple domains in a contiguous space. A DNS record is to provide the information it stores in its database. 8 and 48 records are the main records stored in a DNS database. Additional records contains information about directory services and email and also are configured in the DNS records. We're actually going to talk about the DNS zones and the DNS records later in this lesson. Queries from DNS resolvers, whether originating from a client or a server-based operating system, can take one of two forms: an iterative query or a recursive query. An iterative query is a DNS query sent to a DNS server in which the querying host requests to return the best answer it can provide using its own information and without seeking for the assistance from other DNS servers. A recursive query is a DNS query sent to the DNS server in which the querying host asks the DNS server to provide a final answer to the query, even if that means contacting another server to provide the answer. When sent a recursive query, the DNS server that received the query queries other DNS servers to obtain an answer. To centralize the workload and reduce network traffic, host computers typically issue the recursive queries to the DNS servers. A network of 1,000 clients, for example, querying DNS server is clearly less efficient than centralizing queries to a handful of DNS servers. Centralizing queries means each client sends a single recursive query rather than each client sending multiple iterative queries. DNS servers generally issue iterative queries against other DNS servers if they are unable to answer a recursive query from cached information. By using recursive query, the workload of resolving DNS server can be concentrated to a few servers and thereby achieve much greater efficiency. All clients, whether they are in Windows Vista, Windows 7, or Windows 8 desktop or on Windows Server 2008 domain controllers, act as a DNS clients. DNS clients often are referred to as DNS resolver. Any computer that requires host names to IP address resolution is a DNS client. Windows Server 2008 uses the DNS client service to perform DNS queries on behalf of their client. When configuring a DNS client, you can use the following settings, which provide the DNS client with access to the DNS server and provide information used by the DNS client to properly perform DNS queries. You can do it with DNS servers, or you can do it by DNS suffix. For a client to resolve DNS queries, it needs to know which server to contact. That's where the preferred and alternate DNS servers come in. Your Windows DNS client can be set to use one or more DNS servers for name resolution. The first DNS server in the list is what we call the preferred DNS server. It is the first DNS server your client attempts to query. If preferred DNS server does not respond, the DNS client refers to its list of alternative DNS server one at a time. However, if the preferred DNS server responds without being able to resolve the name request, clients do not query the alternate DNS servers. They simply fail in their query. You can set additional servers or DNS server using the Advanced TCP/IP setting dialog box. Actually, you're going to be doing that in activity 5.5. And also, you can add other DNS server by using net command or interface command.